Guys, if someone is watching me on YouTube or on Facebook, please confirm. Am I audible? If you are watching me on Facebook or YouTube, please let me know. Please confirm if I am audible. Just type yes in the chat if I am audible. If you are watching me on the YouTube, then type yes in the chat if I am audible. Please confirm. Today we are going to see the DMVPN phase 1, 2 and 3 configuration here, and I am streaming this class on my social media platform like YouTube, and here you can ask your doubt in the comment section as well, right? I am checking your comment as well. Okay, so many people are saying audible on the YouTube. Abhishek, thank you. Musadik Bawa, thank you so much for confirmation. Sabbi, thank you. Asmoon, thank you so much. Ritesh, yes, sir, your voice is low. Is my voice low? Here I am able to see voice is okay. Is my voice low? First, I will confirm the voice on all the platform. Whoever are watching me on the Google Meet, right? I am expecting for you everything is okay. For the YouTube guys, people who are watching me on YouTube, please confirm is my voice low? Ritesh, please recheck, because here I think voice should be fine. Okay, sir. Nice. It's nice. Great. Clear. Great. So I am audible on YouTube, and I am expecting my screen is also visible to you. Here I am able to see the screen as well. So hope my voice is clear and my screen is visible. Guys, agenda of today class is to configure phase 1, phase 2 and phase 3. But if you know the GRE VPN configuration, right, the point-to-point VPN configuration between two sites, that is DMVPN phase 1. That is DMVPN phase 1. So we'll not configure the phase 1 because you know phase 1 is nothing but the point-to-point configuration. The most important thing is understanding the difference between phase 2 and phase 3. Phase 2 and phase 3 and the configuration of phase 2 and phase 3, and after that configuring the IPsec to secure our tunnel. So guys, I am asking you to those who are watching me on YouTube. If you are watching me on YouTube, then please can you tell me the difference between phase 2 and phase 3? Can you tell me a single difference between phase 2 and phase 3? What is the difference between phase 2 and phase 3? Or between phase 1 and phase 2? Difference, what is phase 1 and phase 2? Sir, VPN and DMVPN is same. We have multiple types of VPNs. We have multiple types of VPN like L2 VPN, L3 VPN, IPsec VPN, DMVPN. So DMVPN is one type of VPN, right? Both are not same. DMVPN is one type of VPN. We have so many types of VPN. In future, we will have one session on VPN as well, where I will discuss multiple types of VPN, right? The get VPN, remote VPN, point-to-point VPN, site-to-site VPN, or the GRE VPN, DMVPN, IPsec VPN, L2 VPN, L3 VPN, MPLS VPN, right? So we have multiple types of VPN. So someone is saying, Abhishek is saying phase 1 they will register. No, in phase 1 no one is going to register, brother Abhishek. Phase 1 is your GRE tunnel, point-to-point tunnel. In phase 1 you have to configure VPN between all the sites. First of all, what is VPN? VPN is virtual private network. It is a virtual private network. You know, by default two private sites cannot communicate over public network. Like here you can see this is my network of a company. This is network of my company, and 4 sites are there. For an example, I am running one training institute. I am running one training institute with 4 sites. One site is in, let's say, Delhi. One site is in, let's say, Mumbai. One site is in, let's say, Bangalore. And one site is, let's say, in Chennai. You can see my all sites are connected through internet. Internet is public network, and these are my private network, right? So the IP address which I am running inside my company is private. You can see these are private subnet, and the subnet which is running between my edge device and router and internet router is public. Here we have public subnet, and public subnet. By default, even private and public cannot communicate. So the technology which you are using to make communication possible between private and public is NAT, network address translation. Here you have to configure NAT to access internet, and VPN is a technology which is used to make communication between private sites over public network. Like if I want to make communication between these all sites, Delhi, Mumbai, Bangalore and Chennai, these all sites should be able to communicate with each other over internet. So by default they cannot communicate, because here inside my company I am using private subnet, and here between internet and my edge router I am using public subnet, so they cannot communicate. So here we need to configure the VPN. VPN means we will create the virtual network, virtual private network. We will create virtual private network over the public network, right? So if you are going to create one virtual private network between these two sites, 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 that is called your phase 1, right? Here we have point-to-point VPN between two sites, that is called phase 1, that is called phase 1, that is point-to-point VPN. We have point-to-point virtual private network between two sites, and here all sites can communicate. But what is the issue here, guys? What is the issue? CPU usage on the router. You can see here how many tunnels are there, 2. Even here we will have one tunnel between site 2 and site 4. Here we will have one tunnel, right? So you can see 3 number of tunnels are there on router number 2, on branch 2. 3 number of tunnel are there on each side. 3 number of tunnels are there at each side. So who will configure these tunnels? You will configure it manually. You have to configure 3 point-to-point tunnel. So here we have headache on the administrator who is going to configure the GRE, point-to-point VPN. Let's say if I have 100 number of sites in the large enterprise company, then it is going to be very complicated. At every site you have to configure tunnel source and tunnel destination for each point-to-point tunnel, for each point-to-point VPN, for each site-to-site VPN. That is the disadvantage of phase 1. And the another issue is CPU usage, right? If I have 100 number of site, here we will have 100 number of tunnels. Let's suppose, guys, in branch 3 my router is not capable to maintain 100 number of tunnels at a time. If any router is not capable to handle these amounts of tunnel, then how you can reduce the tunnel? How you can reduce the point-to-point VPN? We come up with phase 2 then. We come up with phase 2. Phase 2, why we come up with phase 2? To reduce the load on administrator, right? Now in phase 2 we are not going to configure point-to-point VPN. We are not going to configure point-to-point GRE. We are going to configure MGRE, right? Phase 1 is P2P GRE, phase 2 and phase 3 are MGRE. Phase 2 and phase 3 are MGRE, and phase 1 is point-to-point GRE. Okay? Yes. You are absolutely right. So phase 1, if you know the GRE VPN configuration, you can configure phase 1 here, right? At each site you have to configure multiple tunnels. Like on router number 1, I am going to say interface tunnel 1, then tunnel source, this one, fast Ethernet 0/0, tunnel destination, router 2, tunnel destination, router 3, tunnel destination, router 4, like this. This is going to be point-to-point GRE. But in phase 2 and phase 3, we are going to configure MGRE, multi-point GRE. That is phase 2 and phase 3. right? Again in phase 2, I will configure MGRE on hub router and P2P GRE on a spoke router. Can anyone tell me the difference between phase 2 and phase 3 now? Phase 2 and phase 3. What is the difference between phase 2 and phase 3? Abhishek, Ritesh, Almas. What is the difference between phase 2 and phase 3? Guys, phase 2 is not routing efficient DMVPN. It is not routing efficient DMVPN, and phase 3 is routing efficient DMVPN. In phase 2, you will see we have issue with the summarization. If I want to perform summarization on the hub router, there will be issue, right? In phase 2, two spoke sites will establish the tunnel dynamically. That is fine. We have solved one issue. Yes, automatically create the tunnel between a spoke to a spoke. That is great. In phase 1, if I am running phase 1 here, guys, and in future if I am going to add one new site, here I have to configure hub router as well as the new site router in phase 1. In phase 2, you don't need to configure hub router. Nothing is required. No any new configuration is required on hub router. You only need to configure the newly added router in phase 2 and phase 3. This is the major difference between phase 1 and phase 2. Now I am talking about the difference between phase 2 and phase 3. I will show you the issues in phase 1 practically as well. What is NHRP resolution message? Don't worry about the resolution message. I am going to capture the link. I am going to show you when routers are going to send the resolution message, why it needed, and what is NHRP resolution message, request message, registration message. Okay, so what I will do here, I will directly configure phase 2 in this scenario. I am not going to configure phase 1, right? I am expecting you all know the phase 1 configuration. In phase 1, on all the sites, we will create multiple tunnel, right? 3 number of tunnels are required on router number 1, 3 number of tunnel configuration are required on router 2, router 3 and router 4, right? So I need to create how many tunnels? Total 12 number of tunnels in phase 1. If I have 100 sites, it is going to be very complicated because phase 1 is point-to-point GRE. Now let's configure here phase 2 first and let me see the issues. Let me take you to router 1, guys. The IP addresses are already configured in this scenario. If you will check the public reachability, all the sites are publicly reachable with each other, okay? If anyone have any question, you can ask your question in the comment section. If you are watching me on YouTube and if you have question, you can ask me in the chat. If you are connected on Google Meet, you can ask me directly here, right? So see here, show IP interface brief. Show IP interface brief, exclude unassigned. See, IP address on the router number 1 is not configured. On router number 2, let me check the IP configuration. Oh, IP addresses are not configured. Let me configure IP addresses very quickly first. Let me use Notepad for the IP configuration. Until then, I am going to access these devices. So I am going to configure the scenario from scratch because IP addresses are even not configured. No problem, it will not take much time. But no one has shared the answer in the YouTube chat about the difference between DMVPN phase 2 and phase 3. What happened, guys? DMVPN phase 2 and phase 3. Difference between DMVPN phase 2 and phase 3. Now let me use Notepad for configuring the IP addresses on router. For SD-WAN, this session enable, sir. For SD-WAN, is this session usable, sir? Definitely yes. In SD-WAN, we are using IPsec VPN and the GRE VPN. We have both VPN in SD-WAN, but in SD-WAN, good thing is you don't need to configure. Automatically, your devices will establish the IPsec session or GRE session. Just you need to define the protocol. Which protocol you want to use, GRE or IPsec? Two protocols are there. Enable config T. I'm configuring R1 first. Config T interface F0/0. Say no cert and IP address 1.1.1.1. See, the subnet between router 1 and internet is 1.1.1.0/30. So I will configure .1 on router on my edge router and .2 on ISP side. 255.255.250 exit, and there is one LAN interface F0/1, say no cert, and IP address is going to be 10.1.1.1 255.255.255.0 exit. Right, this is my IP configuration. One default route is required towards internet, so IP dot 0.0.0 0.0.0 exit interface F0/0, next hop IP address 1.1.1.1.2. This is my R1 configuration. Let me copy the command and let me paste the IP these commands on router number 1 for IP configuration. Let me change the host name as well, host name R1, and I am going to save the configuration now. Let me show you. So IP interface brief exclude unassign. See guys, the IP configuration done, and so IP route static. You can see, so IP route static. We have one default route. We have one default route towards internet. Very good. R1 IP configuration is done, and we have also configured one default route. On R2, IP address is going to be 2.2.2.1 2.2.2.1, and on the LAN side my subnet is 10.1.2.1, and default route next hop IP address is going to be 2.2.2.2. and finally let me configure the host name as well. Here I am going to add one more command, host name R2. Okay, let me copy the command and let me paste it on router number 2, R2. What happened here? We have some issue. Let me check where is the issue. Issue is here in the host name, IP route, this one, host name, and then exit. No, everything is fine. Enable IP route command is running in pre-blaze mode. Interface F0/0, interface F here interface is F1/0, sorry, F1/0. Now rest all configurations are correct. Let me copy it and let me paste now on router number 2. Now you can see all the commands are accepted. So IP interface brief exclude unassign IP address, and so IP route static. We have one default route as well. Let me configure R3 now. On R3, IP address on F0/0 is going to be 3.3.3.1, and on the LAN interface it is going to be 3.1, and for the default route next hop IP address will be 3.3.2. okay, and host name is R3. Let me copy command and let me paste these commands on router number 3 now. Done. Then finally on router number 4, IP address will be 4.4.4.1, and on the LAN interface 10.1.4.1, and in the default route next hop IP address is going to be 4.4.4.2. Let me change the host name R4, copy, and let me paste this command on R4. Finally we need to configure internet router now. So let me do one thing for internet router. On the internet router, default route is not required, and on fast Ethernet 0/0 my IP address is going to be C1.1.1.1, sorry 2.1.1.2. on fast Ethernet 1/0 it is going to be 2.2.2.2, and I have one another interface that is F2/0. on F2/0 and F3/0. F2/0 IP address will be 3.3.3.3.3.2, and on F4/0 IP address is going to be 4.4.4.2. Let me change the host name to say internet. Copy the command and let me paste it on internet router. Done. We are done with the IP configurations. Now I am expecting public reachability between all the sites. Let's verify it. Let me take you to side 1, means router 1, and let me ping 2.2.2.1, and you can see ping is working. You can see ping is working. I'm getting the reply message. Let me ping 3.3.3, means router number 3, 3.3.1, and this ping is also working. Let me ping 4.4.4, 4.4.4.1. You can see I'm able to ping router 4 as well. No, router 4 is not reachable. Let me check what happened here on router number 4. Go to R4 and say so IP interface brief exclude unassigned. IP address is 10.1.4.1, 4.4.4. So IP route static. Next hop IP address is 4. Good guys, everything looks fine here. 4.4.4.2. Let me ping to the internet. Here we have some misconfiguration on internet router. See, I am not able to ping the internet router. So IP interface brief exclude unassigned. On F4/0 IP address is 4.4.4.2. Line protocol is up. Sorry, it's not 4/0, it is 3/0. Let me correct it. Interface F4/0. First of all, say no IP address here, and then shut down to this interface. Then go to interface F3/0 and say IP address 4.4.4.2 255.255.255.0, and let me write the configuration. Good. Now I am going to close the console of internet because it is not required, and let me take you to router number 1 again. And now let me ping to the R4. Destination is still unreachable. From R1, why I am not able to ping router 4? Ping 4.4.4.2. Still there is issue. So IP interface brief on F3/0. 3/0 is administratively down. Interface F3/0 say no shut. And now write the configuration. Let me close it. Now from router number 1 I am expecting the reachability. Yes, you can see now I'm able to ping router number 4 public IP address, right? So these all sites are now guys publicly reachable with each other. Correct? These all sites are publicly reachable with each other. If you want, you can create one loopback or the sub interface on switch as well. I am just going to change the duplex here. Duplex, I am saying full. That's it. On switch number 2 also, I am going to configure duplex full because we are getting duplex mismatch error. Config T, interface E0/0, duplex full. It will disturb the log message. Duplex mismatch log message is going to disturb us to understand the DMVPN phase 2 configuration and to check their output. So that's why I'm configuring duplex full on all the switch to avoid the duplex mismatch error. Enable config T, interface E0/0, say duplex full. Done. Very good. Now we are done with the IP configuration and there is reachability, public reachability. Now let's do one thing guys, let's configure DMVPN phase 2. Now who will tell me how to configure DMVPN phase 2? How to configure DMVPN phase 2? First of all, we need to create the tunnel, and let's say on the tunnel, like on my DMVPN, my subnet is 192.168.1.0/24. I will configure .1 on router number 1, .2 on router 2, .3 on router 3, and .4 on router 4. Actually, you know where I will configure this subnet? On my virtual private network. What I am going to do here, I am going to create one virtual private network like this. That is your overlay. Right, I am talking about this network, right? This is going to be my overlay. What is the difference between underlay and overlay? Underlay is physical network, right? See the physical connectivity, physical network which you are able to see here, the physical connectivity is called underlay network, which is my physical network. And overlay is the virtual network which is running on top of the physical network, right? I am going to create this virtual network. This virtual network, right? And where this virtual network will run? This virtual network will work on top of my physical network. And which subnet I will use? Here 192.168.1.1.0/24 on this virtual network, right? I will configure .1 on here, .2 here, .3 here, and .4 here on my virtual network, virtual private network on my VPN. So let's create the virtual network VPN Here go to router number 1. Still I am getting this duplex mismatch error on F0/0 now from the internet. Don't know why we are getting this message. No problem, let me create the tunnel. Say tunnel interface 1. Tunnel interface 1, you can use any number. Then tunnel source will be my fast Ethernet 0/0. Tunnel destination, guys, we are not going to configure DMVPN phase 1. If you are configuring DMVPN phase 1, then here you will define the tunnel destination, right? Tunnel destination can be router 2, or it can be router 3 or router 4 IP address. Tunnel destination, right? But here we are not going to configure DMVPN phase 1, so let me configure the tunnel mode here. Instead of configuring tunnel destination, you will configure tunnel mode MGRE. And if your tunnel mode is MGRE, then you are not allowed to configure the tunnel destination, right? Because one point is not connected to multiple points. There are multiple tunnel destination. Multiple destinations are there. So we cannot define the tunnel destination IP address now. Okay? Clear? Is it clear? Please confirm if it is clear. Instead of configuring tunnel destination, I am going to say what here? Tunnel mode. Tunnel mode MGRE. Tunnel mode GRE, and then multi-point. On the in a spoke 2, on the hub router, you will configure MGRE, multi-point GRE. Lachu Singh, thank you so much for the confirmation. Here I have defined tunnel mode MGRE. Why I am getting duplex mismatch error? This okay, no worry. I will show you the configuration again as well. So here I have defined tunnel mode MGRE. Now if you will try to configure, guys, here tunnel destination. See tunnel destination, and I am saying let's say tunnel destination any IP address 192.168.10.50. So it is giving me the error. It is giving me error, right? The tunnel destination configuration failed on the tunnel interface because your tunnel mode is in MGRE, multi GRE. So you cannot configure the tunnel destination now. Now here I will enable the NHRP protocol. Say IP NHRP network ID 1. Let's say this command will enable the NHRP protocol here. This command will enable NHRP protocol. Then I am saying IP NHRP map multicast dynamic, let's say, right? It is going to map all the multicast message dynamically to the NBMA address, right now here on the router 1. So IP NHRP, I don't have any NBMA address, because in phase 2 what will happen? All the spoke sites are going to register their self on hub router. All the spoke sites are going to register their self. Let me check on other router also. I am getting this duplex mismatch error. No, I'm only getting it on hub router. Config T interface F0/0 duplex full. Close it. Go to router 1 now and say interface F0/0 duplex full. This is the error of simulation. We are getting the duplex error message again and again. So run interface tunnel 1. This is my tunnel configuration till now. You can see this is my tunnel configuration. I have created one tunnel and I said IP NHRP map multicasting dynamically, IP NHRP network ID 1 and tunnel source and then tunnel mode. That's it. Now I am going to configure the IP address on tunnel interface. So IP interface brief. Here you can see your tunnel interface is up, but IP is not assigned. Let me take you to tunnel interface tunnel 1 and say IP address. Which IP address? 192.168.1.1.255.255.255.0. Now I am going to capture this link as well, guys. Link fast Ethernet 0/0 to show you the message, NHRP registration message. Now what will happen on the spoke sides? We are going to configure point to point GRE. On the spoke side we are going to configure point to point GRE, means we will define the tunnel destination. In phase 2, here and on a spoke sides you can also configure the MGRE, right? It will automatically see in phase 2 guys, here it tunnel mode should be MGRE only, not point to point, because what we want dynamic tunnel between two spokes. We want dynamic tunnel between spokes here. So here also mode should be MGRE. Let me configure the spoke router. Go to config T, say interface tunnel 1, and then I am saying tunnel source. Tunnel source is F0/0. Then say tunnel mode. Tunnel mode is going to be GRE multipoint. And here we have to configure NHS IP address, the IP address of hub router. Who is their NHS, right? Like how the spoke router will get to know where I need to register myself, right? So spokes need to register their self on hub router. So here we will configure the NHS IP address. First of all, let me configure one IP here, 192.168.1.2, 255.255.255.0, and after that say IP NHRP network ID 1, and IP NHRP NHS. Who is NHS? 192.168.1.1. This is the NHS, means hub router. R1 is their NHS server. In NHRP there are two types of router. Always keep in mind, in NHRP there are two types of router. One is NHS, means next hop server, and another one is client, NHS, and NHC, client and server, right? So who is server? Server is my hub router. And who is client? All the spokes are your client, right? So I'm going to tell to my client that who is your server. So IP NHRP NHS 192.168.1.1. After that I will map multicast address, IP NHRP map multicast to map multicast to 192.168.1.1, which is the IP address of again hub router, the tunnel IP address of hub. And one more mapping is required here, IP NHRP map. Now see, this spoke router 2 can still not register their self to router number 1 because they don't have NBMA address. Do so IP NHRP, you can see the NBMA address is not there, right? So router 2 know what is the NHS IP address. NHS IP address is 192.168.1.1. do so run interface tunnel 1. So you can see the NHS IP address is there. NHS is 192.168.1.1. But guys, if this router want to send something to this IP address, they need what? Public IP address. They need public IP address to forward traffic over here, right? Means that is NBMA address. So how it will find the NBMA address? All the spoke sites will have the mapping for NBMA address of hub. And how hub router will know about the NBMA address of spokes? All the spokes are going to register their self to hub. It will share. My spokes router will share their NBMA address to hub router. Right? In the capturing, you can see there is no any message of NHRP till now. Now, here I am going to say IP NHRP map 192.168.1.1. This IP address to which NBMA address? 1.1.1.1. Means what is the public IP address of this tunnel IP address? Public IP address of this tunnel IP address is 1.1.1.1. Right? Once I will hit enter, this router will register their self on hub router. This router will register their self on hub router. Wait. do so IP NHRP. Now you can see in the NHRP table, here is one entry, right? This is the tunnel IP address, remote tunnel IP address means the hub IP address, and here is the NBMA address, the public IP address of this IP address, this NHS. This is the NHS, the remote tunnel IP address, and the NBMA address, right? Here we should have the message. Here you can see NHRP registration request message. Who is sending 2.2.2.1 means router 2 is sending one NHRP registration request message to 1.1.1 to router number 1, right? Source public, destination public, right? And after that, here you can see the reply message from hub router 1.1.1. Now on the hub router, like on router number 1, on the hub router, if you will check NHRP table, you will have the NBMA address of site 2. So IP NHRP. So IP NHRP. Here you can see, guys, we have one dynamic entry here. We have one dynamic entry. IP address of router 2, the tunnel IP address, remote tunnel IP address, and here is the NBMA address 2.2.2.1. It is going to expire after this interval of time. And type is dynamic. Type is dynamic means router 1 have learned this NBMA address dynamically. But on router number 2, you can see type is static. On router number 1, we have configured it statically. On router number 2 means on spoke, so IP NHRP. Here we have the static mapping between remote tunnel IP address and their NBMA address means public IP address. And on the hub router, we have entry, dynamic entry here. The spoke router has registered themselves dynamically with the help of registration message, right? So what happened here? Router once I have configured the NBMA address of the NHS, router 2 has sent one NHS. NHRP registration request message. Registration request message, right? And in the NHRP registration request message, it is going to share their NBMA address that, okay, brother, my tunnel IP address is this one and my NBMA address is 2.2.2.2.1, right? And this is how router 1 will learn the NBMA address of spoke 1 dynamically. We need same configuration on spoke 2 and spoke 3 also, like on router number 3 and 4. Okay, for now between headquarter and branch 1, now you can check the reachability. So IP interface brief. Okay, both the routers have the NBMA address. Now if I am going to ping 192.168.1.1 from router number 2, you can see ping is working. Ping is working, right? So in the inner IP header, source IP will be 192.168.1.1, 1.2. Destination IP address is going to be 192.168.1.1, and after that, here we will have the payload as well. Here we will have payload, actual payload. Payload is my ICMP message, and then the exit interface is tunnel interface, so it is going to encapsulate this into the GRE header, and after that we will have the IP of outer header. IP v4 outer header. In the outer header, source IP will be 2.2.2.1 and destination IP will be what? 1.1.1.1, their NBMA address, right? Even in the capturing you can verify that. Here you can see the ICMP request message. In the inner header, source IP is 192.168.1.2, destination IP 192.168.1.1, and here is my actual payload ICMP message, right? And in the outer IP header, source IP 2.2.2.1, destination IP 1.1.1.1, right? Because the spoke sites know the NVMe address of hub router. You have configured the mapping statically, and here is my GRE header. Okay, so hope it is clear. This is phase 2. Now let me perform the same configuration on router number 3 also. Let me take you to R3 and say config t interface tunnel 1 and tunnel source F fast Ethernet 0/0 tunnel destination tunnel source F 0/0 tunnel destination not tunnel destination, tunnel mode GRE multi-point, then IP address 192.168.1.3 255.255.255.0, IP NHRP network ID 1 to enable the NHRP protocol, IP NHRP map multicast to 192.168.1.1, map multicast to the NBMA address 1.1.1.1. Guys, this multicast mapping is required for dynamic routing protocol. Later maybe you are going to configure OSPF or BGP, not BGP, EIGRP, where we have the multicast messages. So over the VPN, over the tunnel, how it will send the multicast address. So it is going to map all the multicast address into 1.1.1.1 into this NBMA address. After that, IP NHRP NHS IP addresses means who is server is 192.168.1.1, and how to reach this server, IP NHRP map 192.168.1.1 to 1.1.1. how to reach the NHS with the help of this NBMA address, this public IP address. And now I am expecting router 3 should also register their self to hub router. Let me take you to R1 and let me check the NHRP table here. So IP NHRP. Now you can see here we have 2 entry. Here I have not 2 entry. Guys, if you are watching me on the YouTube, please hit on like button. Please hit on like button, guys. If you are watching me on YouTube or Facebook, please hit on like button if you are learning. If you have any doubt, you can ask me in the comment section. I am keep checking your comments. If you are learning, then please hit on like button. Please like the video. It will motivate me. If you are going to like the video, it will motivate me. Okay, so now you can see on the hub router I have 2 dynamic entry. Both are dynamic entry, right? This is the IP address of spoke 1, the remote tunnel IP address, and NBMA address to reach this remote tunnel IP address, and type is dynamic. Again, the IP address of spoke 2, and here is the NBMA address of spoke 2, type is dynamic. Clear? Now let me take you to last router number 4. Let me perform same configuration on R4 as well. Interface F0/0. Sorry, I am saying 0/0. Interface tunnel 1, tunnel source, fast Ethernet 0/0, tunnel tunnel mode, GRE multipoint, IP NHRP network ID 1, IP NHRP NHS 192.168.1.1, IP NHRP map 192.168.1.1 into 1.1.1.1, the NBMA address, and IP NHRP map multicast to 1.1.1.1 spoke site. That's it. Now let me take you to router 1 and let me show you the NHRP table. So IP NHRP table. Still we have only 2 NBMA address here because I have not configured the IP address on router number 4. Let me do one thing. Let me take you to interface tunnel 1 again and say IP address 192.168.1.4 255.255.255.255.0. Right now, let me take you to R1 and show you the NHRP table. Now you can see, guys, 3 entry are there, right? Spoke 1 IP address, their NBMA address. Spoke 2 their NBMA address. Spoke 3 and their NBMA address. Right now, even you can verify your DMVPN. So DMVPN, you can see 3 tunnels are there. All are up. State is up. State is up. The tunnel IP address, remote tunnel, and their NBMA address. All the tunnels are up. This is my VPN. This is my VPN on router number 2 or on router number 4 on a spoke side. If you are going to run command so DMVPN, you can see we have only 1 tunnel with 1.1.1 with hub side. And here we have a static. This is a static peer. But on router number 1 on hub router, you can see all are dynamic peer. While troubleshooting, these attributes are going to help you to troubleshoot the issue. Status is up. My DMVPN is up. And all the sites are now able to communicate with each other. That means, guys, here we have created the VPN properly, DMVPN. How DMVPN is created here? Here we have one link. This is my VPN. Forget about underlay network now. Underlay is not required. You can assume this is one switch. You can assume this is one switch. Here, what is the IP address? 192.168.1.1, here 1.2, here 1.3, and here 1.4. Right? Now see what we need. We need to advertise LAN prefixes between the sites. Now what I want, my LAN users should be able to communicate with each other. So what we'll do, we will configure any routing protocol here. Let's say if you are going to configure OSPF, right, network type broadcast, one router will become DR. Let's say this router will become DR, and all the routers will share LSA1 to DR. If you are going to configure EIGRP, again in the EIGRP, all the router will form neighborship, and all will advertise their LAN prefixes. To whom? To hub router. All the spokes are going to advertise to hub, and hub will advertise to spokes. Hub will advertise to spokes. Let me configure the EIGRP routing protocol. You can configure any routing protocol. You can let me know in the comment section which routing protocol you want to configure. Yes, super explanation. Thank you so much, brother Rajkumar. Thank you so much for the appreciation. Please hit on like button. Abhishek is saying like, sir. Thank you so much, Abhishek. Now let me enable the EIGRP router, EIGRP number 10. Let's say network 192.168.1.0, 0.0.0.0.255. No auto summary. This is my EIGRP configuration. Do so. History, same configurations are required on all the routers. Let me copy the command and let me paste this command on router number 2, 3, and 4. Config T, paste the command. Done. Go to router number 3 and paste the command. Very good. And on router number 4 also paste the command. Now here you can see we have EIGRP neighborship. On any router you can verify it. Let's say on router number 1, so IP EIGRP neighbor. So you can see, guys, how many neighbors are there? 2 neighbor, 1.4 and 1.3. Why we don't have EIGRP neighborship between router 1 and router 2? Go to router 2 and okay, now neighborship is up. So IP EIGRP neighbor. Very good. Who is neighbor? 1.1. And on the hub router, now let me check the EIGRP neighbor. So IP EIGRP neighbor. Why I'm getting duplex message here? It is really disturbing me. Config T interface F0/0 duplex full. And so IP EIGRP interface brief. Sorry, not brief. EIGRP interfaces. EIGRP is enabled on tunnel 1 interface. Oh, someone said to configure OSPF. I'm so sorry, brother. I have already configured the EIGRP. No worry, I will configure the OSPF as well. I will show you the OSPF configuration. For the OSPF, you should have good command on the network type. Over the DMVPN in this scenario, what should be OSPF network type? Can anyone tell me what should be the OSPF network type here in the YouTube chat? I am asking to those who are watching me on YouTube. What should be the network type of OSPF if I am going to configure OSPF routing protocol here? What should be the OSPF network type? I'm waiting for your answer. Here we have some issue with neighborship. Q count is increasing here, guys. See on router number 2. Now this is again question. OSPF network type should be, someone is saying non-broadcast, someone is saying broadcast. Okay, forget about the OSPF. First tell me why Q count is increasing here. On router number 2, Q count is 1. On router number 2, Q count is 1. Why? What can be the reason of Q count 1 here? You can see EIGRP neighborship is fluctuating, going down and coming up. Tell me why EIGRP neighborship is fluctuating here. Why EIGRP is not working well? If you want to, why EIGRP neighborship is not working well? Why Q count is increasing and neighborship is fluctuating? Query packet is sent to find the neighbor. That's why Q count is 1. Query message. Where is query message? Here is the capturing. Where is query message? There is no any query message, guys. Update message and hello message are there only. So run interface tunnel 1. See the tunnel 1 interface configuration. Here is the issue. Here is the issue, guys. It should be what? Multicast and then NBMA address of hub. Note 192.168.1.1, the tunnel IP. This is the ccie lab exam question. This is ccie lab exam question. This was the issue in my ccie lab exam. Interface tunnel 1. I am saying no to this command. And after that I am saying IP, NHRP, map, multicast, and it should be 1.1.1. Note 192.168.1.1. Okay. This was the issue. Now you can check. So IP, EIGRP, neighbor. Now EIGRP is stable. You can see Q count is 0. And now on router number 1, you can check the EIGRP neighbor. So IP, EIGRP. Now you can see 3 neighbors are there. Very good. 3 neighbors are there. All are working fine. Q count is 0. Sequence number 4. This neighbor is 4. And spoke 2 and spoke 3. Sequence number is 1. Now let's advertise the LAN prefixes in EIGRP 4. LAN to LAN communication. Here now I am not receiving any route through EIGRP protocol. You can see nothing is there. So let me advertise the LAN prefix. Router EIGRP AS number 10 and network 10.1.1.0. Wildcard mask 0.0.255. Okay. So on hub router I have advertised the prefix in LAN prefix in EIGRP. Now on spoke 1. So IP route EIGRP. You can see spoke 1 is learning the hub site prefix. It is learning the hub site prefix. Yes, na? No, guys, only 22 likes are there on the video till now. You guys are not liking the video. Okay, no problem. No problem. If you are enjoying, then okay, fine. This was just a request. See, here, router 2 is learning the LAN prefix of hub site. Now I can ping to this LAN prefix from router number 2. But LAN user from branch 1 cannot ping, right? In branch 1 we have the prefix of headquarter, but in the headquarter I don't have prefix of branch 1. So let me advertise the branch 1 LAN prefix as well in EIGRP. Router EIGRP as number 10 and network 10.1.2.0. Very good. So and on router number 1 now check. So IP route EIGRP. Here you can see now we are learning the branch 1 prefix, branch 1 LAN prefix. Similarly, you will advertise the LAN prefix in BGP in EIGRP on router number 3 network 10.1.3.0 and on router number 4. On router number 4 network 10.1.4.0. Very good. Now go to any router, let's say router 1 first, hub router, and check the routing table. So IP route EIGRP, you can see 1.2, 1.3 and 1.4. Branch 1, branch 2 and branch 3 LAN prefixes are coming here on the hub router. And now two sides can, these all sides can even communicate. Right? This is my hub router. Let me take you to a spoke router now. Let's say R2 and here let me show you the routing table. So IP route EIGRP. Guys, here we have issue. Here we have issue. You can see we are only receiving the hub side prefix means headquarter LAN subnet. We are not receiving the LAN subnet of branch 2 and branch 3. Now who will tell me why we are not receiving branch 2 and branch 3 subnet on router number 2 on branch 1 router? Why we are not receiving this and this subnet on router number 2 in EIGRP? Here we have EIGRP neighborship, here we have EIGRP neighborship, and here we have EIGRP neighborship. Right? So router 3 will advertise this to R1, R1 should advertise it to other side. But it is not happening like that. It is not happening like this. That's why we are not able to find branch 2 and branch 3 subnet here on router number 2. Why? Tell me in the comment section. Tell me guys. I am talking to my YouTube subscribers. 13 guys are watching me there. Why I am not receiving branch 2 and branch 3 LAN subnet on router number 2, and similarly on branch 2 also you can see on branch 2. So IP route EIGRP, we are only receiving the route of headquarter on router number 4 branch 3. So IP route EIGRP, we are only receiving the route of headquarter. So can two sides, two spokes communicate with each other? No, two spokes cannot communicate. Let me take you to router number 2, and first of all let me ping to head office 10.1.1.1 and this source 10.1.2.1. You can see I am able to ping head office. Branch 1 and head office are able to communicate. But if I am going to ping branch 2 from branch 1 3.1, you can see ping is not working. Branch 1 and branch 2 are not able to communicate. Branch 1 and branch 3 are also not able to communicate, and branch 2 and branch 3 are also not able to communicate. Means two spoke sides are not able to communicate, but all the spoke sides are able to communicate with head office. Why? What can be the reason? Tell me. Lakshman is saying, show me the EIGRP neighborship again. As EIGRP neighborship is fine. You can see so IP EIGRP neighbor. All the spokes has neighborship with hub, and hub has neighborship with all the spokes. So IP EIGRP neighbor. See, all the spokes routers are neighbor, and on the spoke router hub router is the neighbor, only hub on router number 3 also. So IP EIGRP neighbor, hub router is the neighbor. Lakshman, see the neighborship. Two spoke sides are not able to communicate, but all the spokes are able to communicate with head office. Yes, but we have not neighborship between spokes. No problem, no problem at all. If we don't have neighborship between two spokes now, no problem. What I am saying, here we have EIGRP neighborship and here we have EIGRP neighborship. So when this router will advertise some prefixes to this neighbor should advertise it to other neighbor, na? Let's say what I am saying, that here I have a spoke 1 S1 router connected to hub router and another spoke S2, and here I have one LAN, let's say X. So spoke 1 will advertise it to hub will advertise it to other side, spoke 2. So spoke 2 will have the X subnet in the EIGRP topology table and EIGRP routing table. But here we are not able to find that. Why? Because of a split horizon, guys. A split horizon. What is happening? Hub router is receiving routes from spokes on tunnel 1 interface. Tunnel 1 interface, and another spoke neighbor are on same interface. So what a split horizon rule said? Do not advertise the prefixes from the interface where you have received the same prefix. Right? So here we have to disable the split horizon rule. On hub router you have to disable the split horizon rule. Go to R1 and go to then tunnel interface tunnel 1 and say no IP split horizon for EIGRP S number 10. By default IP split horizon EIGRP number 10 is running, right? So I am removing this command. By default it is enabled. Now you can see my EIGRP neighborship is synchronized, and now if I will take you to any spoke router, let's say on router number 2, and you can see here also log message graceful restart of the EIGRP and show IP route EIGRP now. Now you can see I am receiving the prefixes of all other branches. Even on router number 3 you can check. So IP route EIGRP. Now we have prefixes of all the sites on router number 4 also. So IP route EIGRP. Very good. You can see now we are able to see the routing table is synchronized. Everything is fine. Now branch to branch communication will work. Yes, I have disabled the split horizon rule. Now if I am going to check connectivity between branches, branch to branch, ping 10.1.3.1. I am going to ping branch 2 from branch 1, source 10.1.1.2.1, and you can see ping is working, right? But guys, this time branch to branch communication is happening through headquarter. A spoke to a spoke communication is happening via hub router, trace route 10.1.3.1 and source 10.1.2.1 numeric. You can see traffic is going to hub router first 192.168.1.1 and then 192.168.1.3. First traffic is going to hub router and then traffic is going to branch 2, right? So this is B2B communication through hub, branch to branch communication through hub. Is it clear to everyone? Please type yes in the comment section if it is clear. To you guys who are watching me on who are connected to in the Google meeting, do you guys have any question? No, the split horizon rule was earlier enabled on the hub router. Now I have disabled it. After disabling split horizon rule, you can see all the sites are able to communicate. All the sites are able to communicate, but two branch are communicating via spoke, via head office. First my traffic is going to hub office, then it is going to branch, right? So it is behaving like hub and spoke topology. It is behaving like hub and spoke topology. Lakshman is saying yes. Abhishek is saying clear, sir. What about others? 13 people are watching. EIGRP not configured on R1. EIGRP is configured on every router. EIGRP is configured on every router. Guys, now I want a branch to branch direct communication. What I can do? Tell me in the comment section. I want branch to branch communication directly. How two branch can communicate directly? How two branch can communicate directly? Now you can see traffic is going to headquarters. For me, I am late. No problem, you can go through recording later. Here I have configured DMVPN Phase-2, brother. Worst room TV. Here I have configured DMVPN Phase-2 and branch to branch communication is happening via headquarter. But I want direct branch to branch communication. What I can do? How I can configure direct branch to branch communication? Our DMVPN Phase-2, we are running EIGRP protocol. EIGRP. Sir, I just took your CCNA lecture from 4 years back. I feel so blessed to have you, found you, and I want to thank you for doing so much hard work for teaching us. You are a great teacher. Thank you, brother, so much. Thank you so much for the appreciation. Right? These types of comments are really motivating me to work hard. Right? The reason why I am uploading videos every day is your comment only on the YouTube. Right? Your appreciation. You have to configure shortcut. No shortcut is not required here for branch to branch communication. Guys, see why branch to branch communication is not happening. The answer is here in the routing table. So IP.EIGRP. See, branch to prefix 10.1.3.0/24. What is the next hop IP address? Next hop IP address is branch 1, sorry, head office IP address. R1 IP address. Next hop is R1. Similarly, for branch 3 LAN subnet 10.1.4.0/24, next hop is head office. Right? So what is happening? Branches are advertising the prefix to head office because we have EIGRP neighborship here, we have EIGRP neighborship here and here. Right? So let me say this subnet. So branch 2 router is advertising it to hub router through EIGRP, and hub router is advertising it to other side without modifying next hop. Without modifying next hop. Sorry, by modifying the next hop. By modifying the next hop. If my hub router will not modify the next hop, then next hop will be direct branch 3 IP address. R3 IP address is going to be next hop. But what is happening here? My hub router is modifying the next hop. It is updating the next hop. Right? When R3 will advertise this subnet to R1 hub router, next hop will be 192.168.1.3. Right? Even you can verify it on router number 1. On router number 1, you can check the show IP route EIGRP. Show IP route EIGRP. 10.1.3.0. Next hop IP address is 192.168.1.3. R3 IP address. But when this hub router is advertising to other branch, means router number 2, it will set their on next hop. It is updating the next hop IP address. On router number 2, you can see the next hop IP address for this subnet is 192.168.1.1. So R1 has modified the next hop. It has set their on next hop IP address. So I can tell to my hub router that, bro, just do one thing. Hey hub router, do not update the next hop IP address in the EIGRP update message. What I can say, hey R1, do not update the next hop IP address in EIGRP update message. By default, one command is running on router number 1. That is this one, config t. That command is interface f0/0. Command is IP next hop self for EIGRPS number 10. This command is running. That's why it is modifying there. It is updating the next hop IP address. Guys, if I will remove this next hop, command, If I will say no IP next hop self command, will hub router update next hop then? Tell me yes or no. Will hub router update the next hop then? Then what will be the next hop IP address for 10.1.3.0 network? 192.168.1.1 or 1.3, the R3 IP address. If I will remove this command, IP next hop self EIGRP as number 10 from router number 1, then hub router will not modify the next hop. Let me see. Let me hit enter. You can see I have run this command here, and now on router number 2 I am going to show you the routing table. Very good. Now you can see we have same output here, but wait for some time. So IP EIGRP neighbor. So IP.EIGRP. Next hop is still same. Let me clear the routing table once. Clear IP EIGRP neighbor. And so IP route EIGRP now. Sorry guys, I think I did some mistake here. You can see I run this command on F0/0. I should run this command on tunnel interface, not on this interface. I am not running EIGRP on F0/0. Go to interface tunnel 1 and say IP next hop self for EIGRP as number 10 and no to this command, right, on the tunnel interface. Now you can see EIGRP neighborship is resynchronized, and now on router number 2, so IP.EIGRP. Now you can see for 10.1.3.0 next hop is R3. Very good. Now branch to branch communication can happen. Now if I am going to send any traffic to this subnet, router 2 will forward it to this next hop 192.168.1.3. For 10.1.4.0 next hop is R4 IP address. But still we have one issue. What is the issue? Guys, let's say if I want to ping 10.1.3.1 from the source 10.1.2.1, from the source 10.1.2.1, I want to ping this IP address. So if you will ping this IP address, router will check routing table. In the routing table you can see route is there. And what is the next hop IP address? This is the next hop IP address. So we will have the payload here. After that, source IP address 10.1.2.1, destination IP address 10.1.3.1. Then there will be GRE header because exit interface is tunnel interface, and after that outer IPv4 header where it will put the public IP address. Public IP address, source public IP address will be 2.2.2.1, and destination IP address should be 3.3.3.1, right, which is the NBMA address of this next hop 192.168.1.3. But issue is what? Here we don't have NBMA address of 192.168.1.3. Means this router don't know how to forward traffic to this IP address. So IP NHRP you can see. See, in the NHRP table we have only one entry here. The NBMA address of hub router is 1.1.1. Does router 2 knows the NVMe address of 192.168.1.3? No. So IP.EIGRP. In the EIGRP routing table, the next hop is this one 192.168.1.3, but NVMe address of this next hop is not there. NVMe address of this next hop is not there. So again, my first packet will go to hub router, and then second packet will go to spoke directly. Right, direct communication is possible, but not first time. For first packet we don't have NVMe address of next hop. Here is my capturing, you can see on the hub router, and now I am going to ping. I am going to send the traffic. Let's say ping and 10.1.3.1 source 10.1.2.1. I'm pinging. See, ping is working, and now you will check NHRP table. So IP NHRP. Now you can see we have two entry here. One is dynamic entry. Dynamically it have resolved the NVMe address of this IP address, this remote terminal IP address. What is the NVMe address? 3.3.3.1. You know how it has resolved the NVMe address of this IP address? See the capturing. What happened when I ping? When I ping, it has generated on ICMP traffic where source IP 10.1.2.1, destination IP 10.1.3.1, the payload. After that, here you can see one more message, that is NHRP resolution request message. Who is sending? Router 2. So it will send the ICMP message as well as it will send one NHRP resolution request message. Means it is just asking to the hub router that, bro, do you know what is the NBMA address of 192.168.1.3? Do you know the NBMA address of this IP address? And after that, in the response of NHRP resolution request message, your hub router will send reply message. Your hub router will send NHRP reply message. Here you can see resolution reply, request and reply. 2.2.2 is sending, and it is asking what in this message? See, it is asking about the here somewhere you will find that IP address. It is asking about the NBMA address of 192.168.1.3, and then your hub router will see here the NBMA address. Here you can see in the next NHRP registration request message from 1.1.1. 1.1.1 destination is what? 3.3.3.1. This is actually the NBMA address of 192.168.1.3, and then it will learn that NBMA address dynamically. Router 2 will learn it dynamically, right? And now if we have the NBMA address, then my traffic will go directly, right? Now if I am going to trace route 10.1.3.3.1 and source 10.1.2.1, now you can see traffic is going directly. Wait. See, traffic is going to 192.168.1.3 directly, right? Because they have the NBMA address now. So IP NHRP. Again, if I will clear, guys, IP NHRP table, clear IP NHRP. Now show IP NHRP. Now you can see again we have only one entry. Let me check the ping is working now. Ping is working, and now you can see, so IP NHRP again we have dynamic entry, and now trace route. Now traffic will go directly. Is it clear? Please confirm. Shortcut on a spoke and redirect, that is required in phase 3. DMVPN phase 3. In phase 2, shortcut and redirect message are not required. If DMVPN is using at office, means networks, I did not get you. We are running DMVPN here between all the sites. Now you can see again traffic is going directly. But if I will again clear IP NHRP, and if I will trace route now, so you can see traffic is going to hub router and then a spoke side. Again second traffic will go directly, second packet will go directly to branch 2. So one issue we have here, that is first packet is going via hub router, second packet is going directly. Let me check the comment. Many people are appreciating, guys, of my teaching in the comments, so thank you so much for your appreciation. Why removing from R2 speed horizon? From R2 I have not removed the speed horizon, I have removed it from R1. On the hub router I have removed, right? So first packet is going to hub, then second packet is going directly between the sites. Similarly, between branch 2 and branch 3 also we have same output. Now this is your DMVPN phase 2. In DMVPN phase 2, site to site communication is possible, and once this router will learn the NBMA address of branch 2 and branch 3 dynamically. So IP NHRP. Here you can see we have the NBMA address of branch 2. If I am going to ping branch 3, trace route 10.1.4.1 and source again 10.1.2.1. If I am saying numeric, you can see first packet is going via hub router, and now it has resolved the NBMA address to IP NHRP. Now you can see 3 entries are there. NBMA address of 1.4 is also there, right? So now second packet will go directly. You can see second packet is going directly, and once it will resolve it will learn the NBMA address of other spokes, other branch side. It will form the tunnel. Now so DMVPN here you can see here we have 3 tunnels. One is static, and 2 are dynamic. So in phase 2, side to side means spoke to spoke tunnel will establish dynamically, right? And all the spokes will have a static tunneling, a static VPN with hub router. Okay, how it is resolving the remote spoke sites NBMA address with the help of NHRP resolution request message, right? What is happening here? So IP route EIGRP, when this router need to forward traffic to, let's say, this subnet 10.1.3.1, it will check the next hop. This is the next hop. So it will find the NVMe address. It will check their NHRP table. If the NVMe address of this IP address is not available, then it will send first ICMP packet to hub router. At the same time, it will also send one NHRP resolution request message to ask about the NVMe address of this IP address. And after that, hub router already has the NVMe address of this IP address, so it will generate reply. Once it will have the NVMe address, it will try to establish tunnel dynamically. And that's why here we have tunnel. 2 dynamic tunnels are there, VPNs are there, you can see. Now what is the issue in phase 2 then? Praful, everything is working fine. Side to side communication is happening directly. Only first packet is going via headquarter. Then why we come up with phase 3? Can anyone tell me, guys, answer of this question? Now why we need phase 3? See, everything is working fine. First packet, one issue is there, that is first packet, right? You can say that this is the issue, but no problem if first packet is going to hub router, no problem at all. What is the major issue here? What is the major issue here, guys, in phase 2? Because of that, I am going to configure phase 3 here. What is the major issue? Tell me in the comment section. If you don't know, then type don't know in the comment section so that I will continue the class directly. Even I am asking to all the people who are watching me on Google Meet. If you are connected on Google Meet, you can also let me know. What is the major reason of phase 3? What is the issue here you are able to see in this scenario? What is the issue? Tell me. Very good. Very good. Jamil Afrid. It's saying the issue over here is optimized routing and performance. Very good answer. Don't know, Abhishek. No problem, Abhishek. I'm going to tell you. The issue is routing optimization, guys. Routing optimization and performance. For an example, assume now that branch 2 is advertising 1000 prefixes. How many prefixes? 1000 prefixes. 10.1.3.0, 10.1.5.0, 6.0, 100.0, right, 255.0 till there. All the subnets to spokes. This spoke side is advertising all the subnet to hub router. Very good. Similarly, this router is also advertising 1000 prefixes. 1000 prefixes to hub router. No problem. Here we have the good configuration router. It can maintain the large routing table. It can maintain the large routing table. It can install all 2000 prefixes in the routing table. But branch 1 router is, you know, normal configuration router, guys. This router is not capable to install 2000 prefixes. Or if my network is very large, if I am large enterprise where I have, let's say, 100 number of sites, in that case routing table of my spokes router is going to be very large. Routing table size of my router is going to be very large. Now how you reduce the routing table size? If you know that routing, if you know the EIGRP, you can let me know how to reduce the routing table size or database size. Summarization, yes. You will configure the summarization to reduce the size of routing table to improve the performance of your router. To reduce the CPU usage, memory usage on the router, you will configure summarization. See, we have EIGRP neighborship to hub router, very good. So DMVPN, very good. Everything is working fine. But now I need to reduce the size of routing table. Let's say, guys, where I will perform the summarization. I will perform the summarization on hub router, because all the spokes has neighborship with hub router only. So I am going to receive all the individual prefixes from all the spoke sites, and here I will perform the summarization while advertising. For an example, right now router 1 is advertising 3 subnet from tunnel 1 interface. Tunnel 1 interface, one is 10.1.2.0/24, one is 10.1.3.0/24, one is 10.1.4.0/24. It is also advertising 10.1.1.0/24. I don't want to advertise these all 4 individual prefix. Instead of advertising these all 4 individual prefix, I want to advertise one summary address. Let's say 10.1.0.0/16. Just to reduce the size of routing table of my spokes router, I want to perform summarization. So guys, if you will perform summarization in phase 2, again you will have issue. Then side to side communication is not possible directly. Because if I am going to advertise the summary address from the hub router, it will send their own next hop. Right? For an example, let me show you. First, go to hub router, and before doing this, you can see all the sites are able to communicate with each other. All are communicating directly. Right? Traffic is going directly to branch 2 from branch 1. Traffic is going directly in branch 4 from branch 1. See, everywhere traffic is going directly. From branch 2 to branch 3 also you can check. From branch 2 to branch 3. So IP NHRP, here we have only 2-3 entries are there, you can see, but there is no NVMe address of 192.168.1.4. so first packet for branch 3 will again go to hub router, and then second packet will go directly. Trace route 10.1.4.1, source 10.1.3.1. Payload is high. After that, data is going through the tunnel in plain text. No, so that is not the issue of phase 2, Lakshman. Data is going in plain text. That is not the issue of DMVPN phase 2. Right? For that, you can configure the IPsec here. I can implement the IPsec. No problem at all. Now you can see first packet gone via hub router, but second packet will go directly. You can see. So branch to branch communication is happening directly. Right? The plain text data is the not issue of DMVPN phase 2. We can implement the IPsec for the encryption. Issue is routing optimization. The phase 2 is not routing efficient DMVPN. Phase 2 is not routing efficient DMVPN. Right? Even if you want to advertise the default route from router number 1 or the summary route, it will cause the issue. then side to side means branch to branch communication will not happen directly. Let me show you. Go to router number 1 and here on the tunnel interface I'm going to advertise the summary address. Interface tunnel 1 and say IP summary address for EIGRP as number 10 is going to be, let's say, 10.1.0.0, submit mask 255.255.0.0. Done. We are advertising the summary address. AD value, you can set any AD value, leave it on default. Done. Now go to any spokes. Let's say branch 1, and let me show you the routing table. So IP route. Now, so IP route EIGRP. So IP route EIGRP. Now you can see instead of all individual prefix, we are receiving the summary route now. We have only summary route here, 10.1.0.0/16 through EIGRP. And what is the next hop? The hub router. Next hop is hub router. Now all the traffic between branch 1 and branch 2 will go via hub router only. See, trace route 10.1.3.1 to from 10.1.2.1. You can see traffic is going from hub router. All the traffic will go from hub router now. Now branch to branch communication is not possible. This is the issue of phase 2. This is the issue of phase 2. To resolve this issue, we come up with DMVPN phase 3. Is it clear to everyone? Tell me. DMVPN, the difference between DMVPN phase 2 and phase 3 is phase 2 is not routing efficient solution and DMVPN phase 3 is the routing efficient DMVPN. Please confirm in the chat if it is clear to you. Say yes or clear. And guys, 18 people are watching me here. Please hit on like button. If you are learning, if you are enjoying the session, please hit on like button. Please like this video, like this live session, so that the YouTube can recommend it to more guys, more like-minded people. So this is request. Please hit on like button if you are enjoying, if you are learning, and confirm me if it is clear. If hub router goes down, communication will end, all traffic will goes down. Yes, for that you can have backup of hub. We can have multiple hub router here, backup hub. Issue of phase 2 is clear. DMVPN phase 2 is not routing efficient DMVPN and phase 3 is routing efficient DMVPN. In phase 2, direct tunnel between spokes can be formed dynamically. Hub will not change the next hop. Hub will advertise the AJT's next hop. Then side to side communication is possible directly. But we cannot perform summarization on the hub router. Spoke to spoke communication is possible, but we have limitation in routing behavior. There is a limitation in routing behavior in phase 2. And the first packet was going via hub router. That was also one issue in phase 2. Initial packet still goes through hub router. After that, NHRP resolution request message. Every time when you will send traffic from branch 1 to branch 2 from branch 1 or from branch 1 to branch 3 or from branch 2 to branch 3, your router will send one NHRP resolution message to hub router to resolve the NBMA address dynamically. After that, it will form the dynamic tunnel. These are the issue of phase 2. For the first packet, your router don't know the NHRP NBMA address of the next hop. For that, it will send NHRP resolution request message. It learns the NBMA address only after trying to send traffic. Until and unless you will not send the traffic from branch 1 to branch 2, it will never learn the NBMA address of branch 2, guys. Right? Behavior of phase 2. right? Then no support of route summarization or default route. We cannot perform summarization on the hub router. We cannot advertise the default route. Otherwise, now see here. Now if I am going to trace route, all the traffic is going via hub router. Ping is working still, but via hub router. So load on the hub router is high this time. That's why we come up with phase 3. To configure phase 3 here, you just need to run one command. One command on hub router, one command on spoke router. Now I am going to convert the DMVPN phase 2 to phase 3. I am going to convert DMVPN phase 2 to phase 3 now. I am going to convert DMVPN phase 2 to phase 3. See, to convert from phase 2 to phase 3, what I will do, I will run one command on hub router, that is IPNHRP redirect. If you know the ICMP redirect message, redirect feature, how that work, NHRP redirect feature is also working exactly same like ICMP redirect message. If you don't know ICMP redirect message, guys, let me show you where you can learn it. Here in the YouTube, you can search ICMP redirect and then PM networking, let's say. Here is my video, you can see on the redirect message of ICMP. You can watch this video. Let me paste the link of this video here in the chat. Done. And NHRP redirect message also work exactly same. Okay, so let me configure the NHRP redirect feature here, interface tunnel 1, and here I am saying IP NHRP redirect. IP NHRP redirect, this command. Now after running this command, what will happen? If you know the ICMP redirect message, you can answer me. Redirect message, and on the spoke router, you will configure shortcut command. Interface tunnel 1 IP NHRP shortcut, and spoke 2 also interface tunnel 1 IP NHRP shortcut. Now this is DMVPN phase 3, and on router number 4 also config T interface tunnel 1 and say IP NHRP shortcut. Now we have converted the topology to phase 3. Now guys, here is my capturing again. Here is my capturing again. Now again I am going to ping branch 2 from branch 1. Ping 10.1.3.1 source 10.1.2.1. See, ping is working. Ping is working, and here is your capturing. Let me stop the capturing for now. And now if you will trace route, you can see traffic is now going directly. Traffic is going directly in phase 3. Even in the summarization, we have performed the summarization also. So IP route EIGRP, you can see we have the summary route information, but traffic is going directly, right? So in DMVPN phase 2, after summarization, branch to branch communication was happening via hub router. In phase 3, the summarization is also possible, and branch to branch direct communication is also possible. How it is possible? Answer is here in the capturing. You can see this is the first ICMP packet generated by branch 1 router for branch 2, and here is one more message. Who is sending? Hub router. Hub router, guys, right? Which message it is? It is NHRP traffic indicate message. Which message it is? It is indicate message. NHRP indicate message. What is happening here now? Now when you will ping to this side, branch 2 from branch 1, this one from this, right? It is going to check the routing table. Router 1 is going to check the routing table. In the routing table, next hop is hub router IP address. So IP route EIGRP. See, the destination will match in this route, and next hop is hub router. It will forward traffic to hub router because they have the NBMA address. So IP NHRP. They have the NBMA address. It will forward traffic to hub router. When hub router will receive it, hub router will again compare the destination IP with routing table. It will run command so IP route EIGRP. Okay, destination was 10.1.3.1. The destination will match in this routes. Hub router will get to know that okay, I need to forward traffic to 192.168.1.3. Okay, hub router will see that I am receiving traffic on my tunnel 1 interface. Someone has sent me the traffic on tunnel 1 interface, and then I am forwarding the traffic from the same interface. I am receiving the traffic on tunnel 1, and after that I am forwarding the traffic from the same interface, right? That means someone is using suboptimal path. That means someone is not using the best path. Where I am forwarding traffic? I am forwarding traffic to 192.168.1.3. So now your hub router is going to tell to a spoke to router number 2 that bro, you are using suboptimal path. If you need to forward traffic to 10.1.3.1, you can directly forward traffic to this IP address 192.168.1.3, and after that next packet will go directly to 1.3 because your hub router will also share the NBMA address of 192.168.1.3. This is how phase 3 is working. In phase 3 is routing efficient DMVPN. At the same time, it is providing branch to branch direct communication. So DMVPN. Now you can see. Right? Even from router number branch 2 to 3 you can check. From branch 2 to branch 3, trace route 10.1.4.1 and source. So IP NHRP first. Let me clear the NHRP table once. Clear IP NHRP and so IP NHRP. Now you can see we have only one NHRP. Go to config, not config, let me ping branch 3 10.1.4.1 and source 10.1.3.1. First packet will go to hub router, and hub router will send the NHRP indicate message, and after that it will run the next hop. What should be the next hop? 192.168.1.4 should be the next hop. What is the NBMA address? This one is the NBMA address. So now second packet will go directly. 10.1.4.1 and source 10.1.3.1. See, second packet is going directly. This is phase 3. So phase 3 is solving one major issue of routing, right? That's why we are saying it is routing efficient DMVPN. And now, if you are thinking that Praful, this is not secure, my traffic is going in plain text. Now you can implement what, guys? IPsec here. Your traffic is going in plain text. You can see here. See, traffic is going in plain text. Traffic is going in plain text. Anyone can read it. This is ICMP message. See, everything is readable in the human readable language. Is it clear, guys? Everyone, please confirm in the comment. If it is clear, please confirm. So this batch is a weekend batch. This is my weekend batch, and this batch is about to finish. Once I will finish this batch, I will start a new course of troubleshooting for the working professional only. That will be for working professional. That is going to be troubleshooting course. This is not every day daily class. This is weekend class, Saturday and Sunday. Is DMVPN phase 1, phase 2 and phase 3 clear? Hope it is clear. Abhishek is saying clear, sir. What about others, guys? Please confirm. Say yes or clear if it is clear. Now, to secure it, what we can do, we can configure the IPsec here. Go to router 1 and let me configure the IPsec now. Config T. How I will configure IPsec? I will create, I will configure first phase 1, crypto, IPsec, policy number, let's say 10. Policy number 10, and here I am defining the encryption protocol, let's say AES. Then hash algorithm, let's say I am defining the hash algorithm SA. Then authentication, I am going to say pre-shared, and group, let's say 2. Lifetime, let's say 86400. Okay, lifetime. Clear? Thank you, sir. Jamil, thank you so much for the confirmation. Right? Do so history. This is my phase 1 configuration, policy configuration. Let me, this is IPsec, or you can say IKE policy configuration for IPsec. Let me copy the command from here, and I'm going to paste my command in Notepad for other routers. Right? Next thing, for IPsec, just I want to secure my DMVPN. That's why I'm configuring IPsec. Now I will define the pre-share key here. Let me say pre-share key crypto IPsec key IPsec crypto IPsec key. Let's say key is Cisco 123. Key is Cisco 123, and address key Cisco 12 what happened? Crypto IPsec key and after that, okay, for the encryption, let me say 6, and then key is Cisco 123, and address, let's say address is any 0.0.0.0.0.0.0. Let me copy the command to configure pre-shared, and let me paste it over here in your Notepad. After that, we have configured the, we have created the IPsec or IKE version 1 policy. Then we have configured the pre-shared key. Now let me define the IPsec transform set here. Let me say crypto IPsec transform set. Name of my transform set is, let's say, PM, and then ESP protocol is encryption protocol ESP SA. Done. Let me copy the transform set command and let me paste it in Notepad for other sites. So we have configured the transform set. Now let me create one IPsec profile here. Exit, and let's create IPsec profile. Crypto IPsec profile. Name of my profile is, let's say again, PM, or we can say DMVPN. Name of my profile. Then set transform set PM. Right? Do so history, and now finally I will apply it on the tunnel interface. Crypto profile, crypto IPsec profile, and set transform set PM. Very good. And now I will apply it on the tunnel interface. Go to tunnel interface, tunnel 1, interface tunnel 1, and you can say tunnel protection IPsec, tunnel protection, IPsec profile. What was the name of your profile? DMVPN. Enter. Now my all tunnel will goes down. You can see tunnel goes down. So DMVPN status. EIGRP neighborship goes down. So IP EIGRP neighbor. Now you can see there is no EIGRP neighbor. Now your DMVPN is down. You cannot ping to spokes, right? So let me configure this IPsec on all the routers now. Let me copy all the commands and let me paste it on router 2 also. Router 2, all the commands are accepted. On router number 3, and finally on router number 4, right? So see guys, encryption was not the issue of DMVPN phase 2. Someone said that traffic is going in plain text, so that's why I have configured IPsec here, right? Now go to router number 1 and what happens? So IP EIGRP neighbor. I did some mistake here. This here key is already configured, fine. Transform set PM is oh, I need to apply it on the interface here. Sorry, here I have not applied it on the interface. This command is required. On spoke sites, we have not applied it on the interface. So run interface tunnel 1. This command is required on all the spokes router. Go to router 2 and let me interface tunnel 1 and let me enter. Do so history. Let me copy the command. And now here you can see my EIGRP neighborship is again up. Once I will apply it on router number 3. Here also my EIGRP neighborship will come up. And on router number 4 finally. Very good. Now you can check the status again of EIGRP. So IP EIGRP neighbor. All good guys. You can see all the neighbors are up. Here Q count is 1. Just wait for some time. This Q count will become 0. Now you can see the Q count is 0. Now if you are going to see the capturing after sending, you can see all the traffic is now encrypted. If I am going to send again ICMP packet from router number 2, means from branch 2 to branch 3, numeric ping. Where is the ping command? Let me send ping 10.1.3.1 and source 10.1.2.1. let's say repeat 100,000. You can see now how traffic is going guys. All the traffics are encrypted. Now you can see you are not able to read anything, right? So this is how you can secure your DMVPN through IPsec. You can also configure IKE version 2, right? I have configured IKE version 1. Doesn't matter, that is security part. That is not the concept of DMVPN. Our concern is to understand the DMVPN phase 1, phase 2 and phase 3 and hope that is clear to you. Even to secure it, you can configure the IPsec. These are the commands on the interface. After that, you need to apply the IPsec profile on the tunnel interface. That's it. And hope it is clear. Is it clear guys on YouTube? Please tell me, let me know in the comment section How was the session? Please share your feedback in the comment section. And last request to everyone is, if the session was helpful, please hit on like button. Please like the video. It is going to motivate me. If the session was helpful for you, if you enjoyed, then please hit on like button. That's all for today. Today we have seen the DMVPN phase 1, 2, 3, the differences and the configuration, and then finally we have implemented the IPsec IKE phase 1 to encrypt our data. Now branch to branch communication is happening directly, and it is secure because of IPsec. Please confirm. Is it clear? If it is clear, say yes, clear, or type yes, 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 yes. Okay, thanks. Please let me know the next weekend class detail. The next class is tomorrow. Tomorrow we will have a class for MPLS. There are some topics of advanced MPLS. Abhishek is saying awesome, sir. Thank you, Abhishek. What about others? Like the video, guys. If the session was helpful for you, then please like the video. That's all for today. We'll meet again soon. Thank you, sir. Respect from the Pakistan. Knowledge have no boundaries. Thank you so much, Jamil Afridi. Thank you so much, guys. Good night, everyone. We'll connect again. Hope the session was helpful for you, and now DMVPN is clear to you. Bye bye. Good night, everyone.